Alrighty, we're here with questions with 5 for the final test review. Just gotta flip to my notebook real quickly because I just finished the final problems. Alrighty, so essentially it's asking us, given these functions on the left or on the right, which points on this graph match. I failed to mark these correctly, or I just forgot to mark them all together, so I'm gonna do that now. Purple is f1x, and this teal line is going to be f2x. And essentially, what that means is that this f2x is teal line, and this f1x is the purple line. For our first problem, we have to figure out when y is equal to f1 of x, and when y is equal to f2 of x, which point on this graph is where both f1 of x and f2 of x are equal to y. We have 2 points where they both intersect because they're both the same y coordinate. It's going to be B and G. So we're just going to go, what color should I use? I'm going to use green. B and G are our first two. The second one, we're going to look at specifically the purple line, f1 of x, and we figure out where x is 0. Well, x is in fact 0. We're at the y-intercept, which is point E. So we're going to go with E, because x is equal to 0. Next thing, the second function of x, this teal line, and y has to be equal to 0, aka it only sits on the x-axis. That is just going to be point A. The fourth, y is equal to f1x, and then y is equal to 0. So we have to figure out where y is equal to 0, or laying flat down on the purple graph. That's going to be C and D, because they are both equal to, y is equal to 0 in both these cases. And the final one, 5, we have y equals the second function of x, and x is equal to 0. We have to figure out where x is equal to 0. It's going to be somewhere on this y-axis. And believe it or not, the second function is teal, so it's just going to be point F. That is the first question set done, 1 through 5 finished. For the next set of questions, it just like tells you the answers word for word. So just review paper for number 6. Number 7, a parabola needs 3 points in order to be defined, and then hyperbola, which is essentially this thing right here, it's going off on both sides. It just needs 5 points. We're chilling there. Number 8, also just look back on your test paper. If you need anything, I'll just send you the pics of it. I have them done. Number 9 is proper decomposition. So essentially, this is our given equation right here. X minus 2 is over x in bracket x squared minus 9. Our first step to decomposing is to decompose the denominator into a fully fleshed out, which is going to be x minus 3, and then x plus 3. And then we do that really funky a plus b plus c stuff from last week. So you just take one term from each of these equations and then put a, b, or c over it. So our first one is going to be x. We're going to put that over a. I don't use teal again, actually. Hold on. Use purple. We're going to use x minus 3, put it over b, and then x plus 3 is going to go over c. So essentially what you do, you just have to like completely like just break the equation apart into like the widest possible sequence. And that right here is actually, it's just the teal. The teal part's the answer. Because you have to include the equal sign on both sides. And I don't think you actually have to solve. If you have to solve, that's just in a prior video. Number 10, it says, given these two set of equations right here, find the shaded region. Or, actually, I forget. Let me check. Hold on. Okay, yeah, I didn't have my paper with me. It says, which graph is a plot of the system of inequalities? So essentially, when you see the system of inequalities, you're going to have these... My mic unplug? Okay, we are so back. Okay, so essentially what you have are these two greater than or equal signs, or less than and equal signs. You're going to treat these as equal signs, except when it comes to graphing. So for our first equation, which is x squared plus y squared is less than 1. Essentially, when you see x squared plus y squared, that's just a circle, and then we treat this as an equal sign. So it's going to be 1. So it's just going to go out to 1, negative 1, 1, 1. That makes a circle. In order to tell what parameters to put it through, you just take the square root of this, and that'll tell you like how wide you need to make the circle. In this case, the square root of 1 is 1, so it just goes out through 1. And then x, I'm just going to write that x out a little bit more. Or no, that's just y. I'm sorry. It's y is greater than x squared. X squared is just a parabola, which is why it's going up. And now where this weird shading comes in that just makes everything look weird. The purple part, x squared plus y squared, is less than 1. That means everything's going to be contained inside the circle. Because it does not go, because it's less than, goes inside the circle. I have a poor definition of that, my bad. So I would have pretended to put purple here, but I want to use a cooler color, which is red. And then you also include the purple. And then for y being greater than x squared, when y is greater in a parabola, it just goes up. So we have the green here, but we need to find out what both of these have in common. And that happens to be the red region, and the red region is your answer. Problem 11. Row echelon formation. I think it's called. It's row equivalent formation. My apologies. You can go to the paper to get like the 3 answers scribbled off. I decided to expand on it a little bit because I thought they were a little vague and they definitely needed a little more explanation. So let me see my page of my notebook so I can give out the answers. Essentially, there are 2 pieces to the there's 3 pieces to the row equivalent formation. Every entry needs to go down and then to the right in a column. So essentially what that means, do I have extra space over here? If I were to draw out a matrix, and it'd be like 1, 2, 3, 5, 6. It needs to be down and to the right. That's where the next entry needs to be. And these are essentially called pivots. And these are what you use to achieve the row echelon formation. And then there's 2 other prerequisites to it. Oh, I scrolled a little too far. There needs to be zeros below all these pivots. So in the first one, there's 2 zeros. Fourth one, there's 2 zeros, or there's a 1 0. And then there's obviously no zeros below that. So that's what makes it reduced row echelon formation. And then, yeah, the leading row entry just needs to be right. So we have down to the right, down to the right. I do believe it is fine. So let's just say we expanded this just a little bit more. We did like 1 0 0 0 0 0 2 0, and this would still be a valid pivot because it's still down to the right. For reduced row echelon formation, or I don't remember what it's called. It's like reduced row. Yeah, I'm just gonna cut it there. Has to have a non-zero in every single thing that isn't a pivot. So what that means is it has to look something like this. Only the pivots can be a non-zero entry. It's popular to have them all as ones. I don't know if that's technically valid, but if it's not a pivot, it has to be 0. Or the exception to that rule is if the bottom row is all zeros. In that case, this is still valid because this is still just zeros. And then I drew that right there. These are the 2 pivot points, and they're the only non-zero entries, or ones. And then the prerequisite to doing the reduced row echelon formation is you have to have the first form reduced echelon formation first. And that's like the in-depth answer to number 11. Number 12 is the Gaussian thing. 12 is literally just this, um, except it lists out a few more details. Only non-zero can be a pivot in the column. Oh, that's reading out from a different one. I gotta check what the reasons were. If you get a row of all zeros, you made a mistake, the variable is associated with 0, or it's just not a real solution. Essentially what that means is like, let's say, I gotta think my thoughts, hold on. This one right here is a valid answer, because it's not a part of the matrix, because this bottom set is zeros. Essentially the way I memorize this is, since this bottom row is zeros, this is basically the only part you need to worry about for the reduced row echelon formation, because the entire bottom row is zeros, and there is no pivot for it. Next up is matrix multiplication rules. This is super cluttered. How did I write this? We're going to start right here, though. When multiplying a matrix, you just sort it out by row, column, and then times it by the row and column. If the row and column, or the column and row match, that's a valid, you can do that matrix equation. If they don't, you just have to cut it there and say this matrix equation doesn't work. Or you can just flip-flop them around, and if it does work, that's great. And then the outside two pieces, the first row of the first matrix and the row of the second matrix, that will form the new matrix property. Essentially, I explained the examples on here. A 3x2 and a 2x3. This column and this row match, so it's a valid matrix equation. And then the 3 and the 3 from here form the new matrix, the new matrix cell. It'd be a 3x3 matrix, which is this one right here. But for instance, if it was a 2x7 and an 8x9, these two do not match, so you don't get a proper matrix formation, and you can't do the equation. And even if you flip-flop them, it still wouldn't work, because you'd have 2 times 9. That doesn't work. It has to be a 2x2 or a 7x7. And I also kind of felt like I was being a little ambiguous by just having like 3x2 and 2x3, so I decided to like really format it out into this little block right here. We have the 2x2 and a 3x3. I decided to write the numbers out. The 2 and the 3 don't match, so you can't do this equation. But if they did match, your new matrix would be a 2x3 identity. Let me scroll down. Number 14. Never gave us a statement to work off of, so I just wrote called it a day there. 15 is the inclination versus the slope. The first two pieces, y equals mx plus b, is the slope-intercept form. And then 0 is equal to y minus y1 plus m in brackets x minus x1. That's the point slope form. If you just write these two things down, pretty sure you'll just get the question right. And you also have to include the inclination part, which is theta is equal to the inverse tan of change in y, which is basically y1 minus y2 over x1 over x2. This is just the fancy Greek word for saying change in. So basically, your answer will be theta equals inverse tan, change in y over change in x. And if you just write those down in the test with like the numbers he gives you, and even if he doesn't give you the numbers, I'm pretty sure you'll still get some good credit for it. And that's, I think, all the questions on this slide. So I need to open up the next set of slides. Go to the side. Okay, number 16. Number 16 is the angle between the lines. I'm really hoping I didn't unplug my microphone for that last one. Basically, for the last one, if my mic didn't cut out, or if my mic did cut out, if you just write those equations down, you'll be fine. Promise. For number 16, we have theta mark 1, and for the teal, we have theta mark 2. Essentially, and these two lines intersecting, they make this cool little pink angle right there. In order to find out what this pink angle is, we have to assume we know theta 1 and theta 2 first, and then you'll just take theta 2, teal line, minus the angle of the gold line, and that'll give us our pink angle. And that's all he elaborated on for it. Next up is by far the most painful process. You're just gonna have to write these down really large and write down all these cool numbers, because I don't know what they mean. I cannot tell you what these conic sections mean. I'm just writing this down and hoping I get credit for it. Because the thing is a graphical definition. That means to make a drawing of it. I hope this works out. So, yeah, write down ellipse. Write down ellipse here. This ellipse over here is a different problem. You can safely ignore that. And then if we scroll down, we have the parabola and the hyperbola. Make sure you write these little symbols down too. And just write everything down associated with this. This is an R, by the way, and that's a B and an A. That's all I can really pick up from it. Number 18. Over here we are balling. We're balling through this really fast. By far, like the most unknown problems. Parabola, you have to give a graphic definition. Right here is the graphical definition. If you just write this stuff down, essentially, there's three parts of this problem. We have this vertex, which is just teal dot, the purple, which is called the vertex, and then this pink dot with the red line is called the directrix. The focus and the directrix are evenly spaced away from the vertex. So like this line and this line are the same. And let's see here, the distance from the directrix to the focus are something called P. So this is to get to the vertex, it's 1p. To get to the focus, it's another p. And then to get from the focus to one of the angles, or to like the curve, it's 2p across. If you were to go from this point to this point, that'd be 4p. That's called the latus rectum. If you just write that down, we'll be balling. And this right here is like, I don't know how to describe it. It's kind of like figuring out it's for figuring out the focus. That's what it is. So if you ever get numbers, this is the problem. It's x squared equals 4p y. Yeah, I think that's a y. Hope it's a y. So I have my notes on this. Hold on, let me flip the page. Yeah, it's 4py. Okay. And then the focus, I didn't want to write it down because that was way too much work for me to do. So I'm just gonna audibly read you the graphical or the optical definition. The light travels parallel to the axis of symmetry of a parabola and strikes its concave side. All incoming rays of light meet the focus. If you write those words down verbatim, that'll probably fulfill the optical properties. And what that means in drawing is, let's say there's this green line's an incoming white light wave. It's going to bounce and then go directly into the blue dot, which is the focus. And that is the optical property of a parabola. Next up, we got the ellipse, which I believe is the next one. Yeah, we're chilling there. Okay. Put my notebook paper. There we go. There's a lot of parts to this. The first one is that an ellipse is like a weird circle. There's two parts to it, A1 and A2. I'm pretty sure those evenly spaced out. Not quite sure, but I'm pretty sure they are. If you just write down C down here and it goes out to A1, I'll probably get you some credit. The large side of the ellipse is called the major axis, and the smaller side of the ellipse is called the minor axis. Since the ellipse is really flat in this case, it's going to be larger on the major axis, or on the x-axis, which is why it's called the major. And then the smaller side is called the minor. The halfway point, so like if we were to start from halfway and then go to one side, that's called the semi-major axis. And if we were to start from the halfway point on the minor axis, that'd be called the semi-minor axis. This blue line right here is the optical property, which I will now be reading off. A ray of light emanating from one focus, so it comes from A2, reflects off the side, passes through the other focus. So it comes from A2, boink, hits the other focus. The I and the R, I'm not quite sure why it's there, but he put it down, so if you put it down too, you might get some extra credit. And then he put somewhere along it's like tangent or whatever, so like it hits just one spot and then calls it a day. So if you also just want to draw like a line tangent to the circle or the ellipse, you'll probably get credit for that too. Lastly, hyperbola. It's essentially when these two lines go out on both sides. I cannot tell you an equation for this. Oh, I do. I can tell you the equation for this actually. It's y squared minus x squared equals 1 or some other cool number. If I think 1 determines the vertex point, but equals, I was gonna put C or something. Scooby-Doo, unknown symbol. Okay. So where we start off with, you plot the vertex points, V1 and V2, and you'll make those go out like a sideways parabola, or a sideways, sideways parabola. And you'll plot your focuses. These vertexes are both equidistant from this point right here. Okay, different color for that. Hold on. From this point right here, they're both like evenly spaced apart. The part from the center to the vertex is called A. This goes out on both sides too. I'm pretty sure at least. I only drew on the right side because that's what the professor wrote down. And then the side from the center to the focus is called C. You write that down. The y-axis, like this right here, is called the transverse. And then the x-axis, which is right here, is called the conjugate. I hope you can read that in my handwriting. The optical property of it. Outside light directed towards one focus is reflected towards the other focus. So we can use that in the white arrows. This incoming light beam is going to try to hit F2. It's going to be like, nah, I'm not like y'all. It's going to bounce off and it's going to go to the other focus. And yep, that's how the hyperbolas work. That's the last question in the test. I hope that's a good definition. I hope it works out. If you have any other questions, I'll try my best to answer them. I feel pretty confident in the material. So good luck. Love y'all.